next speaker for the day is going to be Dr. Wajid Hussain. Well, Dr. Wajid Hussain is a US scientist and a world-famous expert on outcome assignments for enhanced learning using digital technology and software. He has been a keynote speaker, reviewer, and a presenter in 40-plus leading regional and international conferences. Wajid co-authored a bestseller with world-famous William Spady titled Beyond Outcomes, accreditation at ICEE 2018 Riyadh. He received the top award for Best Scientific Poster Presentation on Capstone Design Process. Let's go ahead and welcome Dr. Wajid Hussain on board.
Good morning, everybody. This is Dr. Wajid Hussain. I've already been introduced, so today we're talking about digital technology to foster lifelong learning skills. What are lifelong learning skills? It's an ongoing, continuous pursuit, self-motivated, self-initiated to acquire latest learning, knowledge, and skills. It enhances competitiveness, enhances employability, inclusiveness, global citizenship, etc. So before we go into the details of lifelong learning, let's look into the relevance with regards to current market conditions. And a good report to look into over here is the World Economic Forum report. We have Saudi Arabia employment profile. We have data provided by LinkedIn, Burning Glass Technologies. We have skills provided by various organizations in order of frequency and relevance, importance, skills like complex problem solving, leadership, social influence, analytical thinking, active learning, emotional intelligence, all of those. The good things about this report is it basically orders different employment specializations, job titles as per their demand, and also lists the skills required by employers. Now, there's something which we call as upskilling and reskilling, which is completely related to context of job conditions, life conditions in which learning or applicability of these certain skills has to align with the conditions that we're talking about. So we have some tops upskilling and reskilling programs for leadership, and this is based on surveys of certain organizations. You could go to any other reports and you can go to more relevant latest reports. You have active learning, you have quality control, and all depends on the various specializations. So this is the background and the foundation for why lifelong learning is so critical, because the content is so dynamic today, and the relevance and the industry you're working with, global conditions, all of these are dynamic. So let's go deeper down into lifelong learning skills, understand them in a more holistic manner. We go to Michael McGarra's research in 2015, but it's still very relevant. And it pretty much sums up the work of many researchers on this topic. And we have lifelong learning skills broken down into some major broad categories. And it's very important to understand these categories and what lifelong learning comprises of, because unfortunately, we have some countries also making their national qualification frameworks, and they list lifelong learning skills and they list problem solving, and that could be a problem. So if you look over here, based on research, we have these three broad categories as one, student thinking. It could be critical thinking, problem solving, and creativity. The other, self-management, motivation, self-initiation, self-regulation, mindsets, etc. And then we have social interaction, emotional intelligence, social values, interpersonal skills are coming into play here. You're talking about teamwork, leadership. So all of these actually interact and compose of the broad lifelong learning skills. All of these are three essential components. So if you want to acquire lifelong learning, you'll have to target all of these three domains, and you have to look into their subcomponents and target which areas of the education process have you to focus on to achieve these. So now, if you look into these three broad categories, student thinking, you have curriculum, instructional strategy, assessment, and quality improvement. 4 areas which you can target student thinking with. And if you look at self-management, you can target metacognition. We'll come to that in a little bit. And we talk about self-discipline, perseverance, and also academic advising. And if you provide the right tools to students to monitor their own performance and their own learning, that can really help. But there's a big problem in current education today. Students cannot look at their own skills. They just look at their transcripts and GPS. That's where digital technology comes in. The other aspect is social and emotional skills. For this, you can target internships, multidisciplinary collaborations, learning values, standards, codes, ethics, and also career counseling. So all of these subcomponents basically help you to address the social and emotional aspect of student learning. So let's move forward and look into how you can integrate these into education. So we list here 4 major aspects which you have to look into. Generally, many, you can say, companies that even develop digital solutions, they look into a certain, you can say, dimension of this multidimensional process. But it's better to look at a holistic, with a holistic perspective. So we have the learning model, the essential frameworks to achieve learning progression. If you don't plan the learning progression, you don't achieve learning. And instructional strategy. Once you have those models in place, what are the instructional strategies to achieve the various levels of learning with the right content and context? And then, of course, when you're assessing those, you need to have a quality improvement process. You have to have documentation from formative and summative assessments and assessments at the course level, the program level, and even when students go out of the program and go into industry or market, you need to have some feedback. And we'll come to that in a bit. So digital technology is basically supposed to harness and integrate all of these aspects. And if it doesn't, and that's the challenge with most of the digital solutions out there today, they're addressing some aspects. They did not integrate all the required dimensions to give the right application and the right results. So let's look further over here. Let's start with progressiveness in learning. And the most common model is Bloom's mastery learning, Bloom's taxonomic model, in which you go from low order skills to high order skills. But the key thing in here is, yes, you have a learning model. You have the 3 domains, affective, cognitive, and psychomotor. But if you look at the European Union and you look at many other countries, we're coming up with a lot of domains. Unfortunately, there's a lot of overlap between the domains. As I mentioned earlier, if you understood what lifelong learning is composed of, you should either select lifelong learning or problem solving, because one becomes a subset of the other. And we have our papers to actually talk about this, because when you create redundancy with the wrong learning domains and their learning levels, which are coming in other domains, you have problems related to assessment and improvement and basically measuring this. So we first talk about here incorporating learning progression into the curriculum. So this on the right-hand side is a cut part of electrical engineering curriculum. It's, however, going to be relevant because I'm not going to go into details of the content here. So first, you identify what are the key lifelong learning skills. And you go to a source such as the World Economic Forum. Here you have critical thinking, complex problem solving, value standards codes, collaborative learning, whatever those are. Then you look into the quality profiles. It could be Washington Accord, it could be AACSB, it could be your national frameworks, national standards. So you'll have to link them together. You don't want to reinvent the wheel. You'll have to align them to each other, because there's a bunch of information in the quality profiles, but the quality profiles could not be 100% relevant to the dynamic nature of the market today. So once you align them, the third step is you identify course modules within the curriculum wherein those specific knowledge and skills can fit in and they can be very relevant. And then you select introductory courses, you select reinforced courses and mastery level courses, which are 3 levels of learning to have that progression. And once you do that, also marked over there is this is based on the ABIT model, but it could be any accreditation model, and you identify lifelong learning at a program level. So this is how you plug in. It's not even just lifelong learning. Actually, you have to plug in all kinds of skills appropriately in relevant course modules and give a dynamic and latest current structure to curriculum delivery. So let's go into the next part, which is very critical. Unfortunately, we find many educators using outcome-based models, but when you talk about answering questions like what's the difference in objective and outcome, they're confused. Objectives, they have future tense, they don't have action verbs, they do not have performance scales, whereas outcomes, it could be program outcomes or course outcomes. Program outcomes are more generic. They do have verbs, they're more generic, they address multiple learning domains and multiple skills. However, the course outcomes are more specific. They would address certain contents of the course, topics, learning activities. However, they could be multiple domains of learning like psychomotor, affective, and cognitive, all in one compound outcome. But what is key is the performance indicator, wherein you zone into a specific verb, a specific activity, a specific learning level, let's say cognitive evaluation. That's a specific learning level. And then you write down the language for that like an attorney. Unless you don't write it down and don't create the technology to capture that, you will not be able to track it all the way in the education process. So on the left side over here, you do see a database, a digital database, and we created that database for about several thousand performance indicators. And now let's look into an example of how you can use these outcomes and implement metacognition. You could use metacognition in a simple homework. And it's not that difficult. That's why you need an assessment outcomes assessment specialist, which is a top job now in US campuses. If you look at on the right side here, there's 32 education interventions. There's metacognition and self-regulation is the top most intervention for learning. You see, now this is a simple homework here. Active filters. What's the difference between active filters and passive filters? And how do you define the advantages and the disadvantages of active filters or passive filters with respect to certain applications? So part 1 is, what do you know about filters right now? And and then you explain what you would do in voluntary, self-motivated learning to acquire the additional learning for comprehensive understanding of the topic. Part 2 is you provide details of all possible sources you plan to utilize for comprehensive learning related to this topic. So the more comprehensive this process is, involving multiple sources, is more credit. So part 3 is you explain all of what you learned. Explain active filters, explain the advantages, disadvantages, explain the applications of these. And then in part 4, you write a conclusion in more than 100 words. You provide a list of references for your research on the topic, why you've selected those sources, why did you go for a certain form of learning, and based on this understanding, what was the most effective, beneficial for you to acquire this learning. And then we have a beautiful rubric called hybrid rubrics. Now, many educators, they write rubrics or they may not even use specific rubrics, but rubrics have to be analytical and holistic and descriptive. And there's a lot of momentum in the education field regarding this. It's more challenging, but you also need the technology to be able to hold these rubrics and present them to both students and teachers at the right time of the education process. So let's move forward. Another great example is the capstone design course, where you go from problem definition, brainstorming, to selecting multiple problems to solve, and then selecting the concept to design and develop the solution. And then you have a method of selection, which is the POOG method. It's relative to engineering, but it does apply to a whole lot of other specializations. It's the concept behind this. So it's addressing all of these major lifelong learning skills. It's an excellent, culminating course. So courses like these have to be identified to spell out all of these stages very, very clearly. We follow them with mathematical models, simulation, the evaluation of manufacturability. Then you go to actual prototyping, and then detail analysis, societal, functional, environmental, sustainability, economic aspects are evaluated. From all of these perspectives, students learn about entrepreneurship, learn a whole bunch of details, and they understand the concept of self-motivated, self-initiated learning to make the project successful. So this is a cut portion of a certain aspect of the capstone design, which is the mathematical model. You have a detailed performance indicator, and you see the various steps listed very clearly. And then we have our papers and additional consultancy to explain how this is done, but this creates the validity and reliability required of assessment and instructions to be aligned to them. So you have these hybrid rubrics, you have the grading components, you can easily translate them to a grading mechanism, and you see that over here. I'm not going to go into the detail, but the key concept here is it's specific, it's classified. You see this is effective domain, it's at internalization, the classification of the outcomes is very clear, and it's indexed, so we know exactly how the student's progression of learning takes place. So the key concept here is to take social science theory, evaluation theory, program theory, to put them all together to develop the technology and the solution. So when you look at social science theory, the theoretical frameworks, is it outcome-based? Everything's mostly outcome-based nowadays in education. So what are the paradigm principles? We come to PADIs, the power principles and paradigm philosophy here. We come to learning models. We come to design-down philosophy. We come to using what is the domain, what are the levels of learning, is it effective domain, receiving, responding, valuing, and then internalization, or is it psychomotor, wherein you go to perception, set, mechanism, complex overt response, and then from there you go to adaptation, origination, or is it cognitive? So you define, because some of these learning levels are not even relevant for certain specializations. So cognitive is very universal, but effective and psychomotor or any other learning domains, all of those fall into the conceptual framework. Then you have the course outcomes, performance indicators, rubrics. All of these have to be integrated into the practical framework, which is called the program theory. You have to have databases. You have to have an evaluation mechanism. The aggregation should be scientific, scientific averaging, weighted averaging. You put proper skill levels together. You don't mix tomatoes with oranges and call it a fruit salad. You have to put evaluation skills with evaluation, average them together. You cannot average evaluation skills with understanding and application skills. And the same way goes for the psychomotor with the affective or the cognitive. This is some hints and indices that I'm pointing out. There's much more detail. There's a continuous improvement management system wherein you take all this information electronically, monitor those for improvement. And let me go a little bit more deeper here. This is a quality process. And we're talking about 6 quality cycles. Now, if you don't have a quality process and supported by your digital technology, you cannot implement lifelong learning. So, and in a matter of fact, any kind of skill. So in the quality process, the quality cycle Q1, we are developing course outcomes, the performance indicators, hybrid rubrics. We're developing the databases, we're creating the whole alignment. In quality cycle 2, we are aligning the syllabi, what we call as the faculty course assessment report, which is a structured reporting mechanism for courses. We are studying those, we are aligning those, we are verifying whether they're according to format. We have an end of term checklist, which we follow so that assessments happen on time and correctly. And then in the third quality cycle, we have a program review. We look into how the outcomes are doing. Are they failing? What is the benchmarking? How is the performance supposed to be adjusted? Is it a course level issue? Is it a program level issue? It's an infrastructure, logistic issue. Is it a faculty related issue? So all those addressed, documented electronically, 1 million documents as a record, a global record in the cloud. We can maintain those and we can monitor those as objective evidence. And quality cycle 4, we look at the performance indicators and we see whether they are actually relevant. They need to change because markets changing, conditions changing, pandemic, or maybe any other global condition, the importance of digital skills. So all of those can be incorporated in a dynamic electronic database. So next is the Q5, which is our quality cycle 5, in which we look at program outcomes. Many schools, they measure outcomes, but very few of them look at a trend analysis. The trend analysis is very key. You have to have a digital system which can monitor the trend of any kind of skills and try to zone in and look into the details of where the successes or the failures are, and look into details whether they're real time or whether they are forecasted results. So all of that ends up with the credit cycle 6, in which we are reviewing the program educational objectives, which are what students do once they get out and they're into the field. We're talking about alumni survey, employer survey, senior exit surveys, and feedback from key stakeholders on how students are doing out in the market. So once you aggregate all of these, then you have a holistic system. So we're talking about the integrated digital quality management system, learning management systems, outcome assessment systems, continuous improvement management systems, and academic advising. Rarely academic advising uses student outcomes. NACADA talks about academic advising, but none, I haven't seen any school from vast research we have done where we find advising based on outcomes. So a student can look at 500 skills over a 4-year period and look into where the skills are failing and where there are strengths and what needs to be reinforced and what needs to be actually addressed for remediation. So we are looking at learning management systems. We have instruction strategy, curricular content, alignment to outcomes, distance learning. We have outcome assessment system. Now, we have to be very clear here. Learning management systems are not outcome assessment systems. So tools like Blackboard, Moodle, and all that, they provide a good learning management system, but they're very weak in outcomes assessment because they do not provide a platform for embedded assessments, and they do not provide a student profile collecting assessment data for every student. That's not provided. So these are the key differences. I'm giving you hints and telex messages. There's a lot of detail here. So you're talking about embedded assessments. You're talking about clear database of outcomes all the way to every individual student. We're talking about continuous improvement management, where a lot of schools have the most difficulty in accreditation because where does the corrective action go? How do basically you reconcile with the failures? What are the action? What's the traceability? Is there a digital ID to the action? How can we trace it? If you have a problem, is it related to curriculum? Is it related to faculty? So all of that can be basically addressed by a holistic digital system that can incorporate the right frameworks. Now we're looking into the administrative assistance system, which is talking about academic advising. Now, all of these we basically utilize in a certain tool which we actually use. It's called eval tools, and I've given some snapshots over here. We have the course assessment report. We have the action items on the left-hand side from committee meetings, and we have meeting minutes. We have traceable actions by digital IDs. We have course portfolios. We have on the right-hand corner detailed skills, hundreds of skills for each student, which they can actually visualize and see very clearly. I will stop at this point, and I'm open to any questions that you have. And the floor is with you at the moment. Thank you.
Thank you for the wonderful session, Mr. Wajid. We have certain questions being posted on the chat if you want to read it out and the answer as well. Thank you.
How do we bridge the gap of what is being taught in online platforms and the outcome? How do we measure the learning? Basically, that's exactly what I was talking in the whole session. If you don't have detailed outcomes and you don't have the learning activities captured in those statements and rubrics, and you don't have the right software system that can provide you that database and that link, it is impossible to achieve that alignment. And that's the problem that we see in today's technology. So it's a very detailed answer in which we usually take some time to present the scientific aspects of these. I think we have another question. What are the key challenges for education institutions to invest in upskilling teachers and technology which will increase their efficiency to online teaching? Once again, I think you have to go to experts who are basically providing digital technology solutions, actually implementing these in their schools, and have some collaborations with these kind of institutions and programs and experts and conferences, and bring in that expertise through specialized training with faculty. Because if you have the wrong models, no matter what amount of training you have or the wrong technology, you can never achieve the kind of accuracy and improvement. You have another question. Pandemic has changed education forever. Will technology be able to find alternatives that enhance student-teacher relationship? Perhaps I would say that, but if you look into the affected domain, I have submitted a paper on that. It's called Industrial Training, a Challenge During the COVID Pandemic. And we find that the affected domain remains a major challenge, and perhaps technology will have limitations that cannot be bridged 100%. So we could see some improvements with immersive learning and other kinds of technologies, but I don't think we'll be able to ever get the reality of in-person relationships and dealings that are there between teachers and students. I think I've tried to be within the time limit. The answers are also very comprehensive, but I'm not able to go into more details. I'll be happy to talk to you with our contact information there. Thank you very much.
A session full of learning was with us. Thank you so much for sharing your inputs, and I personally believe learning never stops.